Okay, so now we're going to work on another one of the gas laws. So last time we did Dalton's law, which was essentially just adding up the partial pressures and coming up with the pressure total. This is Boyle's law, and just like we talked about some of the characteristics of gases last time. So you're going to see some of those characteristics just in this definition. So the definition of Boyle's law states that at constant temperature, so in other words, the temperature is not changing, pressure and volume are inversely proportional. So as I increase the pressure, my volume will decrease. And this is the opposite as well. If I decrease pressure, volume will increase. And it is a proportional relationship. So if I double volume, then pressure will be cut in half. If I double pressure, volume will be cut in half. If I triple pressure, volume will be cut by a third. So it is a proportional inverse relationship. Okay, so before we really start talking specifics here, one of the things we need to recall is what pressure is. And really pressure is when these particles go and collide against the walls of this container. And they're colliding with each other as well, but what's causing pressure is the collision of these particles and bouncing off of these particles into back into this container. And this is a closed container, so they could bounce off this top lid as well, and they're just kind of bouncing all around. So that's what's causing the pressure, is just those collisions. So first we need to look at a formula, and our formula that we're going to use is P1 times V1. So when you have two variables sitting next to each other, we know it's multiplication. So P1 times V1 equals P2 times V2. And again, one of the ways we can see this is that when we're multiplying two variables, that is an inverse relationship when it equals a constant. Now here we're showing a change in. So if I change P, volume will also change. If I increase P, volume will decrease to continue to have these two things equal to each other. And you're going to see that mathematically in just a little bit. Okay, so the relationship, just like we stated up here, is inverse. So as one goes up, the other one goes down. This pressure, as we saw in this picture here, so you can fill in here, happens because of the collisions with the walls. Of the container. Okay, and so what we're going to see here, and this is what we're going to show in here. Let's say I've got, and again, you're going to have more than this. These particles are not going to be this big. This is just a picture example. So let's draw about 10 particles in here. So if this is one of those, pressurized containers where I'm going to use some sort of piston or whatever to push this down, I'm decreasing. You can see that I'm decreasing my volume, making it smaller. I'm not going to change the temperature, and I'm not going to change the number of particles. And so temperature really and number of particles is staying constant. So now I have these 10 particles just in a closer proximity to each other. So if they're closer to each other, they're clearly going to be hitting each other more, and they're going to be hitting these walls more. And so if they're closer and hitting each other more and hitting the walls more, then the pressure is going to increase. And so here pressure will be increased as a result of a decreased volume. Okay, so we just sort of explained that, but the smaller volume over here, just filling in your worksheet, the smaller volume equals more frequent. And really, because they're closer, more frequent and forceful collisions. So now we're going to go through how to solve these problems one at a time. So we're going to have to identify each number as pressure, volume, or temperature. Temperature should be held constant if this is a Boyle's law problem. We're going to write the formula, the equation. We're going to plug in the values, and then we're going to circle our final answer, and don't forget the unit. So let's do a few problems. Mine's a little bit bigger. It should be right underneath there on yours. All right, so first problem. The pressure exerted by a gas is 2 atmosphere. And what I suggest is as you read these problems, you go ahead and start labeling what they are on your problem. So the pressure exerted is 2 atmospheres. So we're just going to write P over that. While it has a volume of, so here's my volume. So this is my pressure and it's pressure 1 and this is volume 1 because the first one's listed. So it's just the easiest way to do it that way. What would the volume be? So here's my question. You see the question tag here, what? What would the volume be? So obviously my volume 2 is what my question is all about. If you're at this sample at standard pressure. Now, here it doesn't give me a number, and so it's assuming that I know that standard pressure is 1 atmosphere. And so I can write that in there for y'all. And we kind of talked about that before, that STP, standard temperature and pressure. So just kind of as a reminder of that. So identified my units and identified my variable and my missing piece. I'm going to go ahead and write the equation out and then just plug everything in where it belongs. So pressure 1, 2.0 atmospheres. I always include my units. Volume 0.35 liters equals pressure 2. Again, we identified that as standard, and so that's 1 atmosphere. And then volume 2 is what's my missing piece. Volume 2. And so these are pretty easy to solve. You can kind of tell it's basic algebra. So I'm going to multiply these two numbers when they're set next to each other. That's a multiplication problem. So 2 times 0.35. And then in order to isolate this variable, I'm going to divide by 1. So in my calculator, I'm going to say 2 times 0.35 divided by 1, and that's going to give me my volume. And if I did that in my calculator, again, you could pause the video and do that in your calculator, kind of make sure that you're set and ready to go with me. V2 is going to equal 0.70 liters. Again, using sig figs, it looks like on all of these, they had 2 significant figures, and so that's why I used 2 here. So there is my answer. Okay, let's do one more, and then y'all should be able to do the other 2 on your own. Sometimes, again, you'll have like a conversion to do. On this one, you didn't have to do that because atmospheres and atmospheres were the same. So if it's not, then you have to look back at the conversions and make sure that your units are the same for the same variable. Okay, number 2. A sample of gas under pressure of 622 kilopascals has a volume of 2.33 liters. The pressure is increased to 988 kilopascals. So this is good. Both of these are kilopascals, and we don't have to do any unit conversions. As long as they match each other, you don't have to do a unit conversion. And so our answer will be in liters for the other one. So that this would be pressure 1, and this would be volume 1. This would be pressure 2. And again, it's asking us what will the volume be at this pressure. So volume 2 is the missing piece. Now it could be pressure 2 that's the missing piece, and it would be the same mathematically, multiply and divide. So this one's kind of set out the same. So write your formula. Plug everything in. So 622 kilopascals times 2.33 liters. Remember, there's a bunch of different units for pressure that you saw earlier. And so pressure 2, 988 kilopascals. And volume 2 is what we're missing. And so mathematically, it's the same as we did before. Multiply those 2 numbers, then divide by this number. So in my calculator, 622 times 2.33, that's multiplication, and then divide by 988. So that's what you're setting in your calculator. And so that's going to be V2. So V2 equals 1.47, 1.47 liters. Need to rewrite that. 1.47 liters is your volume. Okay? And then you can see on the next one that you're going to be doing on your own. This one, notice here, if I were to help you identify, this is milliliters, and actually that's okay. It just means that both of them have to be in milliliters, and so that's okay for them to be milliliters. These would be your volumes, volume 1, volume 2, and here they give you pressure 1. So pressure 2 this time is what you're going to be looking for, which is just fine. And you'll still be multiplying and then dividing, okay? So make sure you set those in. I can label those for you, volume 1, pressure 1, and volume 2. And so pressure 2 is what you're looking for, okay?